Section 1.2, Points, Lines, and Planes. A point indicates location and has no size. When naming it, it is represented by a point named with a capital letter. So in this case, the word point and then A, or you could just write A, and generally that designates the term point. And this is our example of a point in a diagram. A line is a straight path extending in opposite directions with no end, containing infinitely many points. In order to name this, you're going to use two letters with the line indicator above them. Or you could write line AB or line BA. Order for lines doesn't really matter at this point. And then you could also name a line using a single lowercase letter that is not designated to a point. So in this case, line L. So here you see line cursive L. Kind of looks like an E, but it's a cursive L, just floating on the line itself. A plane is represented by a flat surface that extends without end. It contains infinitely many lines. So within a plane, there are millions upon millions of lines, or infinitely many lines. In order to name a plane, you can name it by a single capital letter that is not designated to a point, or by 3 points in the plane. So in this case, A, B, and C. Or you could just name it P, since P is a single capital letter that's not designated to an actual point. A segment is part of a line that consists of two endpoints and all points in between. So a segment is relatively similar to a line, except it has endpoints. It has a defined start and stop point. When you name a segment, you're going to name it using its endpoints. So let's draw an example of segment AB or segment BA. And the symbol for line segment is just like the line, except you don't put the arrows at the end. So here we've got point A, and we'll put point B here, and we draw the line in between. So this would be line segment AB or BA. A ray is part of a line that consists of one endpoint and all the points on the line on one side of the endpoint. Another way to think of a ray is an arrow. So you have a starting point and all the points going in one direction. To name a ray, you name it using its endpoint and then another point on the ray. The order of how you name the letters determines direction. So here we have ray AB, meaning that our ray starts at point A and travels towards point B. So that means, let's say we wanted to do this. We've got A, and we put B here. Our ray has to look like this. Our ray could also look like this. I guess we could go the other direction, put A here and B here. And we've got our points going through, starting at A and going through B. Opposite rays are two rays that share the same endpoints and they form a line. You name opposite rays by their shared endpoint and another point on each ray. So really we're creating a line, but we're using two rays to do it. So both of these rays, CA and CB, start at C. So we'll put C right in the middle. Let's do CA first. So we'll put A here. So going from C to A, we'll go this way. Then CB, going from C to B, we'll put B here. And here we have opposite rays. A postulate or axiom is an accepted statement of fact. Postulate 1.1. Through any 2 points, there is exactly one line. Postulate 1.2. If 2 distinct lines intersect, then they intersect at exactly 1 point. So when 2 lines cross, they meet at 1 point. So we got Postulate 1.3. If 2 distinct planes intersect, then they intersect at exactly 1 line. Here I've drawn a diagram of 2 planes. It almost looks like 2 pieces of paper coming together, and they intersect at that single purple line in the middle. Postulate 1.4, through any three non-collinear points, there is exactly one plane. So if you have three non-collinear, and so non-collinear means not on the same line. So here I've got A, B, and C, and I can't draw a single line that would contain all three at this point, so I know that this is going to define a plane, or it could define a single plane. So here we have some practice questions. It says, what are two other ways to name QT? So in this case, let's assume they're talking about line QT. So we'll put the line symbol above it. All right, so another way to name line QT would be to use either the same points in a different order, or we can choose, because of the line, we can choose other points on the line. So we could use TN or NT. Or in this case, we have the lowercase letter m there, so we could also say line M. All right, and there are other ways to name it. I'm just naming a few. What are two other ways to name plane P? Well, plane P is the yellow box here. So we're looking at, we need 3 points, so we could say the plane symbol, I'm going to go ahead and I'll just write the word plane. So plane, let's say RQV, or we could say plane SQV, or in this case, plane RSV. And I mean, there are others, so let's just leave it there for right now. We've named a few. We just want to make sure we're choosing points that lie in the plane. So now it says name 3 collinear points and name 4 coplanar points. Collinear means they lie on the same line, so we need 3 points that lie on the same line. Well, one set would be R, Q, and S. We can see that right here. Another set would be T, Q, and N. They lie on this line here. Now let's talk about coplanar. Coplanar means they lie in the same plane. So we're just looking for 4 points that sit in the exact same plane. Well, in this case, our 4 coplanar points are going to all be in the yellow. So we're looking at something like R, Q, S, V. Keep in mind, P is not a point because it's just a capital letter used for naming the plane, and it has no point indicator next to it. Here it says, what are the names of the segments in the figure? So we're just going to name some. I'm probably not going to name all of them, just name a few. So segments have start and stop points. So we're looking at DE, we use the segment symbol. EF, we have DF, and then we can kind of mix around the letters. We can say ED, and so on. What are the names of the rays in the figure? So we're naming some rays. So remember, rays have start points. So let's say we have a ray starting at E and moving towards F. Let's say we have a ray starting at E, but this time going towards D. We could also have a ray starting at D and going towards E, or starting at D and going towards F. The same is true if I want to start at F and go towards E. So there are lots of different rays here, and there's still a few more. I'm not going to write them all out. Here it says name a pair of opposite rays. So remember, opposite rays form a line, and they have the same starting point or the same end point. Or, well, I guess the end point is the starting point. So in this case, both of our rays for opposite rays here are going to have the starting point of E. One is going to travel towards D, so we've got ED. And then the other one's going to start at E and travel towards F. So these are our opposite rays. What is the intersection of plane ADC and plane BFG? So we're looking to see where two planes intersect, and they're using this three-dimensional shapes, the sides, as kind of a illustrator of planes, because planes are two-dimensional flat surfaces that go on forever and ever in all directions. So in this case, ADC, you're looking at this top side here. BFG, you're looking at the side here. And so the question is, where do they meet? Well, they're going to meet right here at BC. And remember, when planes intersect, they intersect at lines. So we're not going to write this as a segment. We're going to write this as a line. It's represented as a finite space here, but in reality, planes are infinite. So we're saying line BC. What are the names of the two other planes that intersect BF? So in this case, they're talking about BF here, and they're saying what two planes meet there? Well, we've got the front face here and the side face. The question is, how do we want to name them? I'm going to go ahead and name them using all four letters just to make it clear which ones I'm talking about. So I know plane A, B, F, E is one, and the other one would be plane, let's go with C, G, F, B. You might notice that because I used all four letters, if you look carefully at the naming of how I name the two planes, BF, both letters appear in both names of the planes, and that's a good indicator that your planes actually meet at that point. Just a little trick to use as you're working through your homework. What plane contains E, H, and F? Well, let's see. You've got E, H, and F. So it must be this bottom plane here. So we could write this as three letters and just say plane EHF. Or if you want to write it with all four letters, you can. You can say plane EHFG or EHGF. There we go. What plane contains points A, D, and G? Well, ADG, ADG. So this is a plane that's not actually one of the faces of the shape. It actually cuts across. So this would be like if you took a slice out of this box. Your plane would be kind of diagonal or cut across. And so they want us to shade this. So we're going to shade like what looks like you kind of sliced through the middle or diagonally through the sides. And so this plane would be plane ADG, ADGF essentially, or just ADG. So here, I want you to take a second and list as many facts about this figure as you can using what you've already learned in this section. This could be things like these points are collinear. Tell me where two planes intersect. You can tell me that how to name some planes. You can tell me how to name line segments. You can tell me what opposite rays would be if you can see any. Things like that. There are lots of options here, so just list some of them out, and I will talk about a few of them in class, or if you want to check the notes online.